Alright, today on this video we're going to talk about verifying trig identities. So we're given problems like that shown on the board where you have two sides. And you really have to play on one side of the street. So we're going to only work with the term on the left. It is one big term. And then what we have to do is generate that term, manipulate that term through our trig identity until you get sine squared x. We start with just the two things we know. We know tangent equals sine over cosine. More importantly, we know that sine squared x plus cosine squared x is 1. Again, due to the unit circle. And I see identities with squares in them. In the bottom is 1 plus cotangent squared. So I'm going to make cotangent squared. I know tangent is sine over cosine. And since cotangent's 1 over tangent, it's got to be cosine over sine. So I'm going to divide every term in this identity by sine squared. And if I do that, I get 1 plus cotangent squared x equals 1 over sine squared, which is cosecant squared x. So I know that I can replace this term right here with cosecant squared. So I'll do that first. And put in cosecant squared x. Alright, now I can hold this identity. I use those up, and I probably do those on the side or someplace. So now I'll put those away. Don't need that one anymore. But I got secant squared minus tangent squared. So again, I start from sine squared x plus cosine squared x equals 1. And I want secant, which is 1 over cosine. So I'm going to divide by cosine squared x on all terms. And if I do that, I get tangent squared x plus 1 equals secant squared x. Alright, well, if I move tangent to the other side, we get 1 equals secant squared x minus tangent squared x. And that's the identity I have right there. So if I do that one, I can replace that and put 1 here. And again, I can group this. I've used it. I don't need it anymore. They both came from my identity. My next step I would write is 1 over sine squared x. And obviously we can flip that and get sine squared x equals sine squared x. And I have a verified trig ratio. Alright, the next identity we have here, we're going to verify again, or show that 1 over 1 plus cosine A plus the quotient 1 over 1 minus cosine A is equivalent to 2 times cosecant if I squared that. Again, we're going to operate on one side, we're going to operate on the left. And I notice immediately there are 2 terms on the left side, yet there's only 1 on the right. So I'm going to get a common denominator, and I'm going to add, so there's 1 term. I'm going to multiply by 1 minus cosine A here, and 1 plus cosine A on the other fraction. And when I do that, the bottom is a conjugate of each other. So I get 1 minus cosine squared A on the bottom. On the top, I just get 1 minus cosine A plus 1 plus cosine A, which means those top cosines are going to cancel. I quickly see this again as part of my sine squared x plus cosine squared x equals 1. And I can bring the cosine over. So 1 minus cosine squared x equals sine squared x. So I'm going to do 2 things. I'll find the like terms in the numerator, which are the 1s, and I'm going to put sine squared on the bottom. When I do that, I get 2 over sine squared A. Well, 1 over sine squared A is cosecant squared A, so I have 2 times cosecant squared A, which was our like term, and that is the verification. Okay. The next example we have here is 1 minus cosine squared x in the numerator over secant squared x minus 1 in the denominator, and that's going to equal cosine squared x. So again, I quickly notice in the numerator 1 minus cosine squared x, and I think of sine squared plus cosine squared equals 1. If I move cosine squared, I know the top can be sine squared. At the same time, before I make that step, I know the bottom is secant squared. So again, I think to myself, I want a secant squared on my identity, so I divide by cosine to make a secant. But I have to divide everywhere, which makes tangent squared x plus 1. Again, if I send the 1 packing, secant squared x minus 1 is tangent squared. So I'm going to substitute sine squared for the top and tangent squared for the bottom. Again, I know tangent squared is sine squared x over cosine squared x. Again, we see the sine squareds cancel. Cosine squared will flip to the top, and we have verified the trig identity. Again, sometimes methods are just through practice. Here's an identity that can be very quick. You might think you want to go to one term because there's just one on the right, and there's 2 terms on the left. But I notice right away there's some inverses, so at the very least I want to quickly check by making these just into their cosine and sine counterparts. If I do that, I notice I can flip them up. I get sine squared x. Flip up this one, I get cosine squared x. And I know that is 1, which is equivalent to the other side. A very short and quick proof. You will get the right answer if you use cosecant and secant as a common denominator. It just takes quite a bit longer to get there. Alright, so the last one today, again, kind of a squared mess. We got cosecant squared minus cotangent squared over 1 plus cotangent squared. Again, I'll deal with the numerator first. I see function squared, and you have to think of sine squared plus cosine squared equals 1. I know I want to get a cosecant squared, so I'm going to divide all 3 terms by sine squared, which I do here in this line. When I do that, I get 1 plus cotangent squared equals cosecant squared. Send cotangent squared packing. So cosecant squared minus cotangent squared, the numerator is 1. I've shown that. We know that. So I would do this on the side. So you know that identity works. On the bottom, I see 1 plus cotangent. We just did that a little earlier in the video. Again, I start from my knowledge of tangent and sine plus cosine. If I do the identity again, like I did a few minutes ago, you get 1 plus cotangent squared x equals cosecant squared x. So I can reduce the left side to 1 over cosecant squared theta, which I can retrace that with 1 over sine squared theta. We know 1 over is going to be sine squared theta, which is equivalent to sine squared theta. And we have verified the trig identity. Again, these come through practice. Use your book. Keep on working.